Forget the luxury and the shiny white paint, this is the raw birth of a sky giant. Look at this massive metallic cage. The skeleton of a Boeing or Airbus. Thousands of workers are swarming around this structure, putting in millions of man-hours. Every beam you see, every rib of this aircraft is being hand-cachacked and aligned. It's a breathtaking combination of human labor and extreme engineering, where a pile of metal starts its journey to the clouds. The main body, or the fuselage, looks like the skeleton of a prehistoric whale. These circular frames are the ribs that will hold the cabin's pressure. Teams of engineers crawl inside these tight spaces, connecting the sections with laser precision. At this stage, there are no walls, just the bare bones. Every bolt tightened by these workers is a promise of safety for the hundreds of passengers who will one day sit inside this hollow tube. Before the skin covers the bones, the nervous system must be laid out. Hundreds of miles of colorful wires are woven through the metal ribs. From the cockpit to the very tip of the tail, these wires carry the signals that fly the plane. There are no walls yet, so you can see the incredible complexity of the electrical grid. Technicians spend weeks hand-roping these cables, ensuring that every connection is triple redundant for maximum safety. This is the nervous system of the aircraft, where every signal is critical. Now witness the most critical part of the skeleton, the wing spar. This is the spine of the entire aircraft. It's a massive, solid piece of metal that must carry the full weight of the plane during flight. You can see the workers carefully inspecting every inch of this spar. It's designed to be stiff enough to lift the plane but flexible enough to bend like a bird's wing during a storm. Seeing it exposed like this shows you the true muscle behind aviation. The tail section is being hoisted into place. This vertical skeleton is what keeps the plane stable in the wind. You can see the bare mechanical hinges that will eventually move the rudder, a feat of precision engineering. It's a massive fin made of lightweight composites, bolted on with giant titanium pins for maximum durability. Even without its outer skin, the tail looks intimidating, ready to battle the forces of nature at 500 miles per hour. The skeleton's time in the spotlight is coming to an end as the skinning process begins. Watch as specialized aluminum and carbon fiber sheets are wrapped over the ribs. Thousands of workers use high-pressure riveting guns to hammer in millions of tiny fasteners. This isn't just a cover, it's a pressurized shell. You can still see the skeleton underneath as each panel is locked into. Slowly, the raw metallic cage transforms into the smooth, aerodynamic giant we all recognize. It's a loud, intense, and incredibly precise transition from bone to body. The tail section is being hoisted into place, and it's a masterpiece of skeletal design. This isn't just a fin, it's the plane primary source of stability. Notice the bare mechanical hinges. These are the joints that allow the rudder to move against hundreds of tons of wind pressure. Engineers are bolting this massive vertical skeleton onto the main fuselage using heavy-duty titanium pins. Every alignment must be perfect, because this skeleton is what prevents the aircraft from spinning out of control. Deep inside the nose of the plane, the brain is being installed. Without the fancy seats and screens, the cockpit looks like a high-tech laboratory. Engineers are hand-connecting thousands of wires to the primary flight computers. Every movement of the pilot's hand is translated into electrical pulses that travel through the skeleton to move the wings and tail. This is fly-by-wire technology. At this stage, you see the raw complexity of the avionics. The silent intelligence that will soon guide this 200-ton machine through the clouds. Ever wonder what keeps you warm and cozy while flying 35,000 feet above the freezing cold? Before the luxury seats arrive, the plane gets its internal winter coat. Workers line the entire metal skeleton with specialized insulation. This is vital. At altitude, outside temperatures drop to -55 degrees Celsius, and the engines roar like thunder. This insulation keeps the cabin warm, quiet, and pressurized for your comfort and safety. Seeing this manual labor shows just how much work goes into every single flight you take. It's time for the skeleton to find its legs. The aircraft is lifted on massive hydraulic jacks for the landing gear cycle test. Watch as the giant wheels retract into the belly of the plane and lock into place. You can see the heavy-duty pistons and the thick green hydraulic fluid lines that power this movement. Engineers stand inches away, checking for any signs of friction or leaks. This system must be upper hundreds reliable, as it will survive the impact of thousands of high-speed landings over the next 30 years. Now comes the most powerful moment, mounting the engines. Each turbofan engine is a 30 million beast. In this shot, you can see the engine without its outer cowling stem, a maze of pipes, fans, and combustion chambers. Workers use precision hydraulic lifts to align the engine with the wing skeleton. It's held by just a few massive steel bolts, but these bolts are strong enough to carry the weight of 50 cars. This engine is the heart of the aircraft, providing the thrust and the power to keep the skeleton alive in the sky.
The empty shell is now being turned into a passenger cabin. The transformation begins. Workers slide in pre-assembled galley units and lavatories, building the functional core of the cabin. Hundreds of seats are bolted into floor tracks connected directly to the plane's ribs, forming the passenger areas. Above your head, the oxygen systems and air conditioning ducts are being fitted, ensuring passenger safety and comfort. This stage is a race against time, as hundreds of technicians work in a cramped space, each with a crucial role, transforming a cold metal tube into a comfortable, safe environment for 300 people, ready for the skies. This isn't just about looks. For this aircraft, the final stage is all about protection. In the paint shop, it takes nearly 1,000 pounds of specialized paint to create a shield against rust, UV rays, and extreme temperatures. High-tech robots work with incredible speed to coat the entire plane in a durable, weatherproof formula. But for the final touch, human artistry takes over, adding the airline's signature logo with precision. Once dry, the skeleton is sealed away, hidden beneath a shiny, long-lasting coat that's built to last. Before the first passenger boards, the plane must survive the torture test. Huge machines bend the wings upward to an impossible angle to ensure the skeleton won't snap during a storm. At the same time, the cabin is pumped full of air to test the pressure seals. You can see the metal groan under the stress. This is the ultimate proof of the engineering we saw earlier. The skeleton holds here. It can hold anywhere in the world.
The build is complete. From a bare skeleton to a sky-conquering icon, this aircraft is ready to connect the world. It's a tribute to the thousands of workers who built it and the engineers who dreamed it. I'm Tarek, and thank you for witnessing the birth of a giant. Keep your eyes on the sky. You never know what miracle might be flying above you. Until next time, this is the moment of truth. After years of labor, the maiden voyage begins. The engines roar to life, and the 200-ton giant starts its run down the runway. As the nose lifts, the skeleton we saw earlier finally takes flight. You can see the wings flex slightly as they take the load. For the test pilots inside, it's a symphony of millions of parts working in perfect harmony. The raw metal cage is now a master of the skies.